Okay, question 154. This time we're using integration to find an area. So the first thing we have to do is to find the integral of f of x, where f of x is this thing here. So the integral of that, we've got a function multiplied by another function. It's the integration by parts technique. So I'm going to make u, is it best to make u cos x or u the polynomial? Well, if we make u cos x, then we'll be integrating the polynomial and it's going to make life worse for us. So I'm going to choose u to be the polynomial and dv dx to be the cos x. So when I differentiate u, I get minus 2x minus 3, and integrating dv dx gives me sine x. So v is going to be sine x. Popping those into the formula for integration by parts, u times v minus the integral of v times du dx gives me this. But I've now got another integral which is still a function times a function. So I've got to use integration by parts on this too. Just tidying it up to begin with, to take this minus into the brackets there, change the signs. So I'm going to make u equal 2x minus 3 again, the polynomial again, and dv dx equal the sine x. So then differentiating u, I get 2, and integrating dv dx, I get minus cos x. So popping that into the integration by parts formula again. There's the first part there, and then this is u, v, minus the integral of v times du dx. So minus a minus is a plus, and the integral of 2 cos x is 2 sine x. I'm also tidying this up a little bit. So there's my expression for the integral. And I've got sine x here and sine x here, so I can bring these 2 sine x's into the bracket there to make that 6. So that's the integral of f of x with respect to x. So the next part is to find the area of the shaded region. A shaded region, the lower limit is 0 clearly, but what's the upper limit here? That's the question. What upper limit do we use in the integral? Well, to find out the answer to that question, we need to find the roots of the equation. Where does f of x equal 0? Where does this thing equal 0? So that will equal 0 when either this equals 0 or this equals 0. So either 4 minus x squared minus 3x equals 0 or cos x equals 0. Well, when you factorize this, you find that x is minus 4 and 1. Well, the minus 4 is over here somewhere on the x-axis, but 1 is one of the ones that we've got here, so one of these two roots is equal to 1. Cos x equals 0 gives us x equals minus pi over 2 and pi over 2. The minus pi over 2 will be over here somewhere, we're not interested in that, but the pi over 2. So one of these roots is 1 and the other root is pi over 2. The smaller of these two is the root we're interested in, and 1 is smaller than pi over 2, so therefore the upper limit on our integral is 1. So we want the integral from 0 to 1 of f of x. So we already know what the integral of f of x is. We did that on the previous part of the question. So we're just substituting the values 1 and 0. And when we do that, this whole thing becomes 2. So that's 2 sine 1 minus, and then that becomes 5 cos 1. And when we substitute 0 into this, sine x becomes 0 cos x becomes 1, so this becomes minus 3. So we get minus 3. So popping that into the calculator gives us the area, which is 1.98 square units, complete and accurate to 3 significant figures. Okay, that's it.